Good day, my dear students, and welcome to again to our physics class. And for today's topic, I'll be discussing electric field. And in our previous discussion, so I discussed the electric charge and the electric force, and now I'll be discussing electric field, which is the two previous topics are also connected to this one. So without further ado, allow me to give you a little recap of the following. And again, in the electric charge, we got here the 1.60 times 10 to the power of negative 19 coulomb. So it's either positive or negative. So this value is referred to the charge of the two subparticles of the protons and electrons. So this help us to determine the net electric charge of a certain charges. Okay, so as we determine the net electric charge, dito natin malaman if ito ba ay quantized or not. So again, yung quantization or quantize, it is when a certain elementary charge are in discrete values. Ibig sabihin, multiples of 1.60 times 10 to the power of negative 19 coulomb. So it's either you divide, you multiply, as long as po napasok po siya or divisible po siya sa charge sa po yan, the 1.60, and that's it. The elementary charge is quantized. Now, if naging 0.59, 0.58, or something you added, no, or remove, doon natin na masasabi na pwedeng yung electric charge natin are not quantized. Okay? Now, for the electric force, I discussed with the F is equals to K, the constant, multiplied to charge 1 to charge 2 over R squared, where this R squared is the distance. So, itong formula po natin kay electric force is for the coulombs. Okay? And in this discussion of the electric field, I'll be using the formula of E is equals to F, which is Newton, over this charge. And the other one is E is equals to K, constant, multiplied to charge over R squared, or the distance. Okay? And allow me to give you a little review. So in terms of electrons flow, negative to positive. Why? Because electrons are always free flowing. So they are the one who transfer. Okay, they transfer their energy to positive. Now, for the electric field line, it is a positive to negative. It means that the positive was be attracted by the negative. So, yun naman yung nagiging flow, just like what you see here in the illustration. Okay, and again, for the electric force, depends on the charge and its location, and like charges repel and unlike charges attract. Now, our main objective here is for you to describe an electric field as a region in which electric charge experience a force. So, paano po yun? Paano po natin ma-describe to electric field? So, ano mo muna yung electric field? Electric field, it is a positive test charge, a certain positive test charge experience a force, which is a vector sum of the forces exerted by the charges on the rod and two spheres. So, to make it short, in a certain electric field, a certain charge should have or should carry a certain magnitude for it's not to disturb or affect other charges, because if this test charge doesn't carry or doesn't have a certain magnitude, it may also attract other charges and may cause of disturbances. Okay, especially if this object of certain object, okay, a non-living object or non-matter object, is only wanting a specific charge. However, because if its magnitude, strong magnitude, a higher magnitude, affects also others. Okay? That's why we need to determine its electric field. Okay. For example of this one, the positive test charge has a magnitude of 3 times 10 to the power of negative 8 coulomb and experiences a force of 6 times 10 to the power of negative 8 Newton. As you can see here, okay, and as you can observe here, we got the positive test charge, which is 3 times 10 to the power of negative 8 coulomb. And we also have a force of 6 times 10 to the power of negative 8 Newton. And the formula that we're going to use here is E is equals to F over Q, Why? Because on this first part of letter A, we need to find the force per coulomb. Okay? Why force per coulomb? Because the unit here in the force is N, and the unit here in the test charge is coulomb. And there, we can say that, we can conclude that the unit that we're going to use to determine the electric field is Newton per coulomb. Okay? Now, let us now write the following given. So, we got the 3 times 10 to the power of 8 coulomb. Now, we're going to, as for our Q, and for F is 6 times 10 to the power of negative 8 coulomb, and E is unknown. Now, we can now apply this to our formula. So, we can use this where E is unknown and our F is 6 times 10 to the power of negative 8, and our test charge is 3 times 10 to the power of negative 8 coulomb. From there, we can get force per coulomb of 2. Now, the second problem or the second question here is we're going to predict the force. How are we going to predict the force? So definitely, we're going to derive this formula. So we can use this pyramid where we put F on the top and at the bottom, the E and the Q. And sabi dito, nawawala daw po ang force, and therefore, we are going to multiply. That's why the second formula we're going to use here is F is equals to E multiplied to test charge. And there, our electric field is the 2 Newton per coulomb. And when we apply the following given to this equation, okay, so ito po ang lalabas niyan, 2 Newton per coulomb multiplied to 12 times 10 to the power negative 8 coulomb, we will get 24 times 10 to the power of negative 8 Newton. Okay? Now, in the definition of this electric field, again, we are determining the exist point of a certain electrostatic force experienced by a small test charge placed at that point divided by the charge itself. Okay? So, definitely, we are referring to a certain point of the electric field. So, hindi mo siya kukunin ng buo. Kung saan mo siya gustong i-obserbahan, mamaya, ipapakita ko sa next slide, no? Doon mo lang siya madadetermine. Now, again, force is, the unit of force is Newton, and the unit for the test charge is coulomb. And definitely, the electric field unit will be Newton per coulomb. Now, allow me to ask you a question. So, what is the difference between these two? What is the direction of the magnetic field lines and electric field lines? Okay, so if you're going to observe, there you will come up with the different answers. Okay, but then again, these two are completely the same. Okay, so however, their interactions are different, but in relation, they're simply the same. Why? Magnetic field, their directions line form a closed loops. They merge from North Pole on this end, entering to the South Pole. Now, they never intersect, and they indicate that the strength of a certain magnetic field, closer line means stronger field, and open lines are weaker one. Now, the direction of the magnetic field at any point is tangent to the field line at that point. For the electric field, it radiate outward from positive charges and converge inward toward negative charges. It means that there is a attraction. So they never cross, and the density of the lines indicate that the strength of electric field. Closer lines means stronger field. So as you can see, their behavior are different because the other one, considering has a closed loop, which is the electric field also determine a closed loop. However, again, it depends on the attraction. Okay, that's why this electric field and magnetic field are always intertwined. For example, electromagnetic field or the EMF waves. Kung saan nyo narinig yung red waves, blue waves, ultraviolet waves, and so on and so forth. So this help us to determine if there is a certain attraction or the strength of the signals. Ayan, doon natin siya na-determine, doon siya na-apply pagdating sa ating mga community. Now, so here is the magnetic field image. So you can see, nagkakaroon siya ng closed loop, then the rest is scattered, no? Kalat. Now, if you will be encountering this kind of problem where if there's some point and surrounding charges that create electric field at given point, okay, what will you do on the charges on the two metal spheres and the ebonite rod that create an electric field at the spot indicated? Okay, now the field has a magnitude of 2 Newton per coulomb, and we need to determine the force on the charges in A and B. So, again, the formula that we're going to use here is E is equals to F over test charge. Now, meron po tayong magnitude dito, which is the Newton per coulomb, and we need to determine the force. Therefore, we'll be deriving the formula. So, F, E, and the test charge. So, nawawala ulit ang force. So, the formula that we're going to use is F is equals to E multiplied to test charge. Now, so let's try this one. On the letter A, as you can see, we have test charge of positive 18 times 10 to negative 8 coulomb. And for the B, we have a test charge of negative 24 times 10 to negative 8 coulomb. So with the use of this formula of F is equals to E multiplied to test charge, our E here, or the electric field, the magnitude is 2 Newton per coulomb, as it was being stated in our problem. Now, let us write the given or for the letter A. So, sulat ko muna dito. So, the A here is 2, and then our Q here is 18. So, the charge, the integer will be absolute. Okay? I said to negative 8 coulomb, and the other one is E2 Newton per coulomb, and then our Q here is 24 times 10 to negative 8 coulomb. Okay, so at this point we're going to write in the equation. So you'll get here, so ayun na, the answer na rin siya. As you indicated that, or you put that in our equation, you will get 36 times 10 to negative 8 Newton. Okay? And for the letter B, pag nilagay natin siya sa equation, you will get 48 times 10 to negative 8 Newton. So, it is easy, right? So, you just simply derive the formula, understand the problem, and write always the given para hindi ka din nalilito. If you need, please also take note, okay, there are some problems that you need to convert some values. For example, microcoulomb, you need to convert it to coulomb, nanocoulomb to coulomb, okay? Now, as you can see, we get here is 34 and 48. So we got here 34 times 10 to negative 8 column, and the other one is 48 times 10 to negative 8 column. And as you can see, since the test charge is positive, the force point in the same direction as the electric field as part of the drawing. So therefore, based on our free body diagram, positive po ang magiging sagot ni A. Sa B naman po, sabi dito, the force of the negative charge points in a direction opposite to the force on the positive charge. That is opposite to the electric field. So also, this 48 will be positive. Why? Kasi nga po, opposite sila. Opposite sila ng direction. Okay? Now, what will you do? Or before that, our next objective is you're going to calculate the electric field due to the system and Coulomb's law. So, ito naman po ay integration na po ng Coulomb's law sa ating electric field formula. Okay? Now, what will you do if you encounter this kind of problem? According to our problem is, So the A and B each contribute as follows to the net electric field at point of vector A, 3 Newton per coulomb, directed to the right, and vector B, 2 Newton per coulomb directed downward. Now, vector A and B are perpendicular. What is the net electric field at point? So point here is here. Ito ang point natin. And we're just simply determining the net electric field and if they are perpendicular. So what we'll be using here is a Pythagorean theorem, okay? And to find the theta is we'll be using the inverse tan, where the vector B divided by vector A. Now, please take note of the following, and we're going to put that in the equation. Okay, so the reasoning here that the net electric field is the vector sum of vector A and vector B. And this give us the answer that the vector A and B are perpendicular. So the vector is a diagonal of the rectangle shown in the drawing. That's why we use Pythagorean theorem and trigonometry. Now, for our theta, what we get here is 33.7 degrees. Okay, so please take note of this kind of formula to integrate in the vector sum. Next example is when the isolated point charge of 0.80 microcoulomb is in a vacuum, the test charge is 0.20 meters to the right. It has a charge of 15 microcoulomb. Determine the electric field at point P. So, which of the two of this formula we're going to use? Okay. So, these two formula are both will be used, or these two will be used. Why? Because we need to find first the force. Okay? So as you can see, although they are they're not separated, but this one is isolated, but we have the two charges here and we have the distance. And we need to determine again the electric field at point P. So for us to able to get this one, we need to look for the force. Now, so the formula that we're going to use here is the Coulomb's law. Okay, so where F is equals to K multiplied to charge 1 and charge 2 over R squared. So when we put that in the equation, 8.99 times 10 to the power of 9 multiplied to 0.80. So paano po naging 0.80 times 10 to negative 6? So you just simply divide microcoulomb 2, divide nyo lang siya sa 10 to the power of 9. Oh, sorry, to the power of 6. Kapag nanocoulomb, you convert the value to 10 to the power of 9. So just simply divide. If you want, you may also multiply it to divide. Or multiply nyo siya to microcoulombs equals to 10 to negative 6. Pag nanocoulomb naman po, pwede naman po ay 10 to negative 9. Okay? So which is which, they will work in both ways. Okay? And there, you'll get 2.7 Newton. So as we get the 2.7 Newton, we multiply to the test charge 0.80 times 10 to negative 6 coulomb, and you will get 3.4 times 10 to power of 6 Newton per coulomb. So that's we are going to use that. Okay? Next. Now, the electric field does not depend on the test charge because the point charge in electric charge point is considered to exist at a single point and thus having neither area nor volume. And this point is space that has an electric charge that exists only at theory and that cannot be measured. So, the formula po kapag po hindi present si force, we'll be using the E is equals to K to test charge over R squared. Kapag hindi available si force, okay? Now, pag nandiyan naman si force, we'll be using E is equals to force over test charge. And also, if papahanap talaga, no, si force sa inyo, yung magnitude, we'll be using the Coulomb's law where F is equals to K multiplied to charge 1, charge 2 over R squared. So, lahat po sila ay naka-absolute value, no? Now, these two positive charges, the example naman natin, separate charges naman to. The two positive charges, Q1 is equals to 16 microcoulomb and Q2 is equals to 4 microcoulomb are separated in vacuum by a distance of 3 meters. So, find the spot on the line between the charges where the net electric field is 0. And with this one, check natin yung mga given. We have the Q1, 16 microcoulomb, and Q2 as the 4 microcoulomb. As you can see, they are separated. Therefore, we'll be testing this one na dalawa. So, where E1 is equals to E2. Now, we need to convert the following. So, 16 microcoulomb, that will be 16 times 10 to negative 6 coulomb. And the other one is 4 times 10 to negative 6 coulomb. Now, if we're going to put that in our equation, like this one. Now, assuming, bakit nandito si 3 meters kay 4, if you will notice, in a Cartesian plane, we focus that here in the x-axis, no, in our x-axis. Now, in our x-axis, okay, here is our point. Now, the average of, yun ang point natin, no, the average of the distance of the Q2 is here. And the total distance is 3 meters. So, we can say, or we can assume that Q2 has a distance of 3 meters from Q1. That is why the distance of Q1 will be unknown. That's why we're going to put the distance here. Now, for us to be able to get the distance, is we need to subtract the distance from the 3 meters. Okay? And this, we need to cancel out everything. So, allow me to rewrite this solution. So, K And then multiply to 68 times 10 to negative 6 is equals to k to 4 times 10 to negative 6 over 3 meters minus d squared. Now, cross multiplication lang po tayo dito. So, put it here and put there. So, mangyayari po dito is 16 times 10 to negative 6 over 4 times 10 to negative 6 is equals to d squared over 3 meters d squared. Ayan. Now, multiply lang po, divide lang po natin to. Divide lang natin yan and you will get 4. So, 4 is equals to d squared over 3 minus d squared. And there, you will get cross multiplication. So, show po natin dito na meron tayong 1. So, cross multiplication, ayan. And from there, transfer lang ako dito. So, we got the 3m. Oh, sorry. Ano tayo dito? Lalabas na d squared is equals to 4 multiplied to 3m minus d squared. Para matagal po yung squared po natin, we put square root. Cancel, cancel, and squared lang po natin ito. Yeah, squared lang natin, and you will get d is equals to 2, then 3 meters kasi naka-bracket siya, no? Naka-parenthesis. So, di siya pwede maggalaw. Oh, sorry. Wala na pala yung squared. Yan. After that, distribute lang po natin. So, 2 times 3, that will be 6 meters. And then we got here the 2D. So, si 2D naman po, transfer lang po natin dito. So, lalabas na D plus 2D is equals to 6 meters. So, derive pa natin ulit. That will be 3D is equals to 6 meters. And we'll divide this 2 into 3 para matanggal yung para makuha natin yung D, no? Tanggal yung 3. And divide natin siya sa 3. And there you will get D as 2 meters. Okay, so we use the algebraic expression to this one. Integrate natin siya dito. So, sa ating formula. And that's how we're going to deal with it. Okay? Now, and for the last of this problem, so we got here the electroreception in an animal ability where they can detect with the electric field of 5 times 10 to the power of negative 7 Newton per coulomb. Now, in every small fish, they carry a negative 0.1 nanocoulomb in creating the electric field. And with this one, the formula we're going to use here is E is equals to K multiplied to test charge over R squared. However, the problem here is we're going to determine the distance. The maximum distance of the shark could be away from the fish and still detect it. So, mapapansin po natin dito, distance ang pinahahanap po natin. Distance ang pinahahanap sa atin. Therefore, we're going to derive this formula and what we will be using is R is equals to square root of K multiplied to test charge over E. And we need to convert this 0.1 nanocoulomb into coulomb, where 0.1 nanocoulomb is 0.1 times 10 to negative 9 coulomb. And with this, so when we put the following given to our equation, and we use again the 8.99 as our K constant, and our test charge is 0.1 times 10 to negative 9, which is, that is 0.1 nanocoulomb. Kinonvert lang po natin siya sa coulomb, no? And we're going to divide that to the electric field of the shark, which is the 5 times 10 to negative 7 nanocoulomb. And we will get the 1,340 meters. And that's the distance for the shark, no? To determine the fishes, to determine the following the fishes. Okay. So therefore, this having the ability to detect small electric fields even a few meters away allow the shark to locate food that might be hiding beneath sand, for example. So ganun kalakas yung radar, no? Let's say the magnetic field para ma-determine agad ng shark yung mga fishes na nagtatago or along the way sa pag-swim ng mga sharks sa ating sea. Okay? And with that, for our next topic, we shall be discussing this one on my next video. So the electric field lines, and this will be a very short and an introductory for Gauss law. Okay? So if you have further questions, just simply message me and I'll be happily answering your questions. Thank you and God bless.